All right, today we're going to tackle one of the most powerful mathematical ideas ever. Seriously, it's a tool that is literally running on your phone right now, in your headphones, all over the internet. What is it? We're talking about the Fourier Transform.
Okay, to get our heads around this, let's start with a really simple idea. Imagine someone hands you this amazing, super complex smoothie. Now, what if you could do more than just, taste it? What if you had a machine that could tell you the exact recipe right on the spot?
Right, so you take a sip, and what do you get? You get everything all at once, right? The banana, the strawberries, the yogurt, it's all just one combined flavor. That's the final product. If we were to graph that experience, it would look like a single, kind of messy signal that changes over time as you drink it.
But the recipe, now that's a completely different way of seeing things, isn't it? It's not about the combined taste over time. Nope, it's just a simple list of the ingredients and exactly how much of each went in. 2 bananas, 10 strawberries, a cup of yogurt. Simple as that.
And that, right there, is exactly what the Fourier Transform does. It is that magical machine. It can take a really complex, messy signal, let's say a sound wave, and it spits out the exact recipe. It tells us which simple, pure frequencies or ingredients were used to make it. It literally uncovers the hidden recipe.
So to really get how this machine works, you've got to understand that it's basically a bridge between two different worlds. They're just two ways of looking at the very same thing. We call them the world of time and the world of frequency.
And this table here just lays it out perfectly. So, on one side you have the time domain. That's the smoothie itself, right? The final product. Think of it like the waveform of a song in an audio editor, showing how the sound changes over time. But then, on the other side, you've got the frequency domain. That's the recipe. It's like the equalizer on your stereo, with those little bars showing you exactly how much bass, mids, and treble are in the mix. Same song, two totally different views.
And this really gets to the huge breakthrough idea from the mathematician Joseph Fourier. His big aha moment was realizing that any signal, no matter how complicated and messy it looks, is actually just a bunch of simple, pure sine waves all added together. That's it. And the Fourier Transform? Well, that's the tool that figures out exactly which sine waves and how much of each you need.
Okay, so how does this thing actually work? How does a piece of math unmix a signal and find all the ingredients? Well, it's actually a pretty cool and elegant process.
So here's the best way to picture it. First, imagine taking your signal and wrapping it around a circle. Now this circle is spinning at a very specific speed, let's say 10 times a second. Okay, so here's the clever part. If your original signal has a rhythm that just happens to match that spinning speed, a 10 Hertz ingredient, then all the peaks in your signal will start to line up on one side. The whole shape gets lopsided. The machine sees this shift in its center of mass and goes, aha, and it records a big spike. That spike is the confirmation we found a 10 Hertz ingredient in our smoothie.
And it doesn't just stop there. The machine just keeps doing this over and over and over. It spins the circle faster and faster and faster, checking for a match at every single possible frequency. And what you get at the end is this beautiful chart that shows you the strength of every single ingredient. It's the complete recipe for your signal.
Now, I know this might all sound a bit, abstract, right? Like some math exercise. But its impact is so real. In fact, this whole process of unmixing signals is literally happening all around you, right this second. So let's talk about where.
Think about it. Every single time you listen to an MP3, or put on noise-canceling headphones, every time you look at a JPEG image, or even just connect to Wi-Fi, you are using the Fourier Transform. It is the silent, unsung hero powering so much of our digital world. It's constantly translating signals from that smoothie world of time into the recipe world of frequency.
Let's take MP3s, for example. How do they work? Well, to make a song file smaller, the first thing a computer does is use the Fourier Transform to get the sound's recipe. Then it does something really clever. It just throws away all the ingredients, the frequencies, that our ears aren't very good at hearing anyway. Then when you press play, a reverse process called the inverse Fourier Transform takes that simplified recipe and rebuilds the sound. And the result is amazing. You get a file that sounds pretty much identical, but it's 10 times smaller. Wild, right?
Now, you might hear a couple of acronyms thrown around when people talk about this, so let's quickly clear them up.
See, computers don't see perfect smooth waves like we draw them. They see a series of snapshots or digital samples. So the version of the transform that's built for that is called the discrete Fourier transform, or DFT. But we need this stuff to be, well, fast, for things like real-time noise cancellation to work. And that's where the fast Fourier transform, or FFT, comes in. It's just a super clever, incredibly fast algorithm for doing the DFT. It's really the engine that makes all this magic happen in the blink of an eye.
Okay, let's wrap this all up. If you need to explain this to someone else, here's the whole idea in a nutshell. This is your quick explainer.
It really is this simple. Think of a musical chord. When we hear it, it's just one single sound, right? That's our smoothie. But the Fourier transform is what gives us the sheet music. It's the recipe that tells us, hey, that sound was made up of a C, an E, and a G note. That's all it is at its heart. It's a way for our devices to see the individual ingredients of the world around us, not just the final mixed-up product.
And that kind of leaves us with a pretty fascinating thought, doesn't it? The Fourier transform revealed this whole hidden layer of reality, breaking down sound and light into their basic parts. So it really makes you wonder, what else out there works like that? What other complex things, in nature, maybe in the stock market, or even in our own biology, are really just a mix of simple, hidden ingredients just waiting for the right tool to come along and show us the recipe?